This is a part of a question from the 2017 DEB mock exam where you were asked to write Tn, the nth term for sequence B. So sequence B is this one here that goes 1, 3, 6, 10. So if we look at the first difference is 2, 3, and 4, so we can conclude from that it doesn't have a constant first difference, so it's definitely not linear. So go on and look at the second difference, and you can see the second difference is 1, which means we have a constant second difference and a constant second difference means that the sequence is quadratic. So we've been asked to find an expression for Tn, the nth term of sequence B, and we've now established that sequence B is quadratic. So any quadratic sequence will have this form: an squared plus bn plus c. And once you know the second difference, you can figure a out. So 2a equals the second difference. And that little outcome or whatever, you just have to learn that. That's how you get a. You let 2a equal the second difference. So our second difference is 1, so we let 2a equal 1, so therefore a is half. So now this sequence here has simplified a little. It's a half n squared plus bn plus c, because now we know. So what you do then is you're going to use your first term and you're going to use your second term. So when you're talking about the first term, the fact that it's the first term means that n equals 1, and in this sequence, if I just scroll back up, the first term over here is 1. For the second term, n is going to equal 2, and the second term in this sequence is 3. So we take the sequence, this one here, as we have it, and we're going to do a half 1 squared plus b times 1 plus c, so replacing the n's with 1, and we know that the answer to that is 1 from here. So if we simplify that, 1 squared is 1 times a half is a half, b times 1 is b, c, and then 1, and then we take this over here and it'll become a minus, so we get b plus c is 1 minus a half, which is just a half. Is that okay? Then do the same thing over on this side. So we get a half times 2 squared plus b times 2 plus c, and that equals 3. So we get here 2 squared is 4, half of 4 is 2. Right, so we try that again. So 2 squared is 4, half of 4 is 2. b times 2 is 2b, plus c equals 3, and do the same thing we did in the other one. You take the 2, bring it across, so you get 2b plus c equals 3, and then the 2 comes across and becomes a minus 2, so it's 3 minus 2, which is 1. This other one here, the fact that we have 2 unknowns, b and c, and 2 equations means we're going to do a simultaneous equation, and where, if you can help it, don't use fractions in a simultaneous. So I'm going to get rid of the fraction here by multiplying by 2, so I get 2b plus 2c equals 1. So now I have my simultaneous, which is 2b plus 2c equals 1, and 2b plus c equals 1. So I'll cancel the b's by multiplying the bottom line by minus 1. So I get 2b plus 2c equals 1, and the bottom line becomes minus 2b minus c equals minus 1. So that's c equals 0. Sub that back into the first one, so 2b plus 2c equals 1 becomes 2b plus 2 times 0 equals 1. So that's 2b equals 1. So b is a half. So the Tn that we have here, it was a half n squared plus bn plus c. We can fill that in now to being a half n squared plus a half n plus 0. Sorry, not c, 0. And then you don't need to write the 0. So it's a half n squared plus a half n. So that's the nth term, Tn, for this quadratic sequence. So the method will stay the same every time, obviously just the numbers will change.